Hi students, today we are going to solve quadratic equations, and I am going to work out most of the even problems that are on your assignment sheet. So we are going to start off with problem number 2. Now, the objective is that you would copy your notes as I go through it, and then you'll be able to complete the assignment 11 through 13 odd. So your assignment that is due is, 1 through 13 odd. And I will work the even problems for you in the notes. So problem number 1, we have x squared minus 19x plus 84. What we're going to have to do is, because this is squared, this is not a linear equation, this is x squared, we're going to have to find the two places, squared means 2, that the quadratic touches the x-axis. So in our problem, we are going to have to factor our quadratic. And you know that x squared is x times x. And you're trying to look for two numbers you can multiply together to get 84. And then when you add those numbers, it's going to have to give you 19. Well, the factors, there are a lot of factors for 84, and I happen to know that 12 times 7 is 84, and if I add 12 plus 7 together, it would give me 19. Now, the big number comes first because the big number gets the first sign, and since they need to give me negative 19, and right now I have a negative 12, I'm going to put a negative in front of that 7, because a negative 12 and a negative 7 gives me a negative 19. And if I multiply negative 12 times 7, I get a positive 84. That equals 0. Now, there is a product rule, the zero product rule, that says if one of these is 0, and you multiply 0 times any number, you're going to get 0. So what we do is we set each one of these factors equal to 0. And we solve for x. So if I add 12 on both sides, I get x equals positive 12 on my first factor. And over here, if I add 7, I get x equals 7. So the solution to this quadratic is both 12 and 7. In other words, if you graphed this quadratic, it would touch the x-axis at positive 7 and at positive 12. So let's look at another example. This is example number 4 from your assignment. It is x squared minus 17x plus 60 equals 0. So since x is squared, I'm going to factor it to find my two solutions. So x squared is x times x. Now 60, the number 60. 60 has a bunch of factors. It can be 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and that's it. So we're trying to figure out which combination could I add together and get 17. And that's this 5 and 12. So put your big number first. And the big number gets that first sign, so I have a negative 12, and I need a negative 17. So this needs to be a negative in front of that 5 so that they get me a negative 17. So now that I have my two factors, I'm going to set each one equal to 0 and solve the equations. So when I move this negative 12 over, I get x equals positive 12. When I move the negative 5 over, I get x equals positive 5. So again, what did I do? My steps are I factor, I set my factor equal to 0, factors equals 0, and then you solve. So now we're going to kick it up a smidge. This time we are going to look at number 8. We're going to skip on down to number 8. We have 15x squared plus 14x plus 3 equals 0. Since my line leader, my leading coefficient in front of x squared, is not 1, I'm going to look for a GCF. Is there a number that will divide to both 15, 14, and 3? And unfortunately, there is not. So this is going to be kind of a guess and check kind of deal. 15x squared. I'm going to try 5x and 3x. Okay, now 3 is either 1 times 3 or 3 times 1. If I try 1 times 3, this is the belly button math. You need to multiply your innies together. 1 times 3 is 3. There's my x. And then 5x times 3 is 15x. Could we add these two together? We're saying we're adding them together and get 14. No, we cannot. So I'm going to have to erase. And I'm going to try a different combination. Instead of that time I tried 1 and 3. This time I'm going to try 3 and 1. So multiply my innies together. 3 times 3x is 9x. 5x times 1 is 5x. And yes, I can add and get 14. If I add these together, I get 14. I want a positive 14, so they both need to be positive. So now, I finally got that factored, and I need to set each one of my factors. I kind of lost my x here. Equal to 0 and solve. So to solve the first one, I need to move the 3 over. So this is going to give me 5x equals, and when I move the 3 to the other side, the equal sign becomes a negative 3. Then divide by 5. That cancels, and I get x is a negative 3/5. My second set of factors, when I move the 1 over, I get 3x equals negative 1. Then I divide by 3, and this is x equals negative 1/3. We could not have graphed this and found these fractions on the graph. That's why factoring is an important step. So let's try another one, kind of more challenging one, like number 8. So we're going to do number 10. We have 56x squared minus 17x minus 3 equals 0. Now again, my line leader is not 1, so I'm looking for a GCF. And there's not a number that will divide into 56, 17, and 3. So we're going to have to factor using the guess and check method. So pencils really are helpful right now. All right, 56. 56 is 7 times 8. So 56x squared is 7x times 8x squared. 3. 3 is 3 times 1. So I'm going to try this combination. 3 times 8x is 24x. Multiply my outies together. 7x times 1 is 7x. Now pay attention. Are we going to add them or subtract them this time? Use this second sign. You need to be able to subtract and get 17. Could you subtract these two numbers and get 17? Yes, we could. Since this has to be negative 17, I want my bigger number to be negative. So the innies gave me the big number, and my outies, they have to be the opposite sign in order. So the outies have to be the opposite in order to subtract. So I have a negative 24, a plus 17 would give me plus 7 gives me a negative 17. Now that I have my factors, I'm going to set each one equal to 0. And I'm going to solve. So, solving the first one, move the 3 over and I get 7x equals positive 3, divide by 7, and you get x equals 3/7. On the second one, move the 1 over, and I get 8x equals negative 1, divide by 8, and x is negative 1/8. Okay, so I am going to have you do problems 1 through 13 odd. And have a great weekend. You know what? Let's cut this down. If you watch the video, then you will find out that I am making you do only 1 through 9 odd. But if you don't watch the video, they can do the other two. So here we go. Have a great weekend.